This is Britt Caswell with another example video. In today's video, I'm covering example 2 from lesson 6-1 in the SavvasRealize Algebra 1 textbook. In this example, I'm using what is called the product of powers property. So the product of powers property occurs when you have two numbers that have the same base, and I'm multiplying them together. So do you see how this one has a base of A and this one has a base of A? You can only use the product of powers when the bases are the same. Okay, so I'm going to put that as a little note here. Only works when bases are the same. Alrighty. And so what we do is when we have that same base that we need to have, we can go ahead and we can add together the exponents. Alright, so for example, 3 to the second times 3 to the third, you can add together the 2 and the 3 for the exponent and you get 3 to the fifth. Or here, when you have x to the second times x to the fourth, right, the 2 and the 4 we would add together. And we could take this a step further and we could call that x to the sixth. Alright, now this is a problem that I just came up with a little nilly-willy just to make sure that we are aware of what to do. Okay? So, oops. Here we are, I have x to the third times x to the eighth. So when I go to multiply this together, right, they have that same base, which is x, and then I need to add these exponents. So I get x to the 24th. And so this yellow triangle is my answer. Oh, what am I doing? I didn't add. Silly Miss C. 3 plus 8 is 11. I fell into my own trap. So here's a couple things that I want to give you a heads up on. In another couple of examples, you're going to learn that if you have what's called a power of a power, so when you have a single base with an exponent raised to another power, so something like this, x to the third to the eighth power, you would multiply the exponents together, which is what I did in my head for a second there. Also, in a little while, you're going to learn about what's called the quotient property, which is when you have exponents stacked. So if I had x to the eighth divided by x to the third, I would subtract the exponents to get x to the fifth here. And then the most common mistake that I see with students when they're just starting this is they remember to add the exponent, which is great, but then for some reason they also add the coefficient. So just remember, the only time you add coefficients is when you're adding together two expressions. So this one would arise if you did x to the 11th plus x to the 11th. Okay? So there we have it. That's how to use the product of powers. Now your textbook, instead of showing you a lot about the product of powers, they kind of get a little heavy into it. Okay? And so they give us problems kind of like this, which I thought was a bit extreme. That's why I did this little mini example. Now remember, when you have the same base, which in this case I have a base of 3, and I'm multiplying the two expressions together, we can combine them into a single expression where those exponents are being added. So in this case, I could take the left-hand side of the equation and I could call it 3 raised to the power of x divided by 2 plus x divided by 3. Ooh, that's messy. Let me rewrite that. There we go. And that's still equal to 3 to the 9th. Now this next step that I do only works if the bases are the same, okay? So what I'm going to do is I'm going to take my exponents and set them equal to each other. So I get x over 2 plus x over 3 is equal to 9. And then I'm going to solve this. Now when you have a problem like this where you have these kind of ugly fractions that are stopping you from doing stuff, what I recommend doing is just multiplying the entire problem by whatever the least common denominator is. Alright, so in this case, between 2 and 3, my least common denominator would be 6. So I'm going to multiply everything in this equation by 6. And watch what happens. So this is like x divided by 2. So if I'm multiplying by 6 and dividing by 2, I can take the 6 and just divide it by 2. So this turns into a 3x. Now here, I have x divided by 3. So if I'm multiplying 6 to all this, I could do 6 divided by 3. And that gives me 2x. And then here, 6 times 9 is 54. And now that I've done that, now this is a little more familiar for us, right? So I can go ahead and combine my like terms. Just giving myself a little more room. I can combine my like terms. So 3x plus 2x is 5x. And then I could divide by 5. And that'll get me x equals, I'm going to call it 54/5. But you could convert that to a decimal if you really want to. I just prefer fractions. All right, so let's try this again. Okay, so the first thing is that we can combine this using the power or product of powers property. So because the bases are the same, I can call this 2 to the x divided by 4 plus x divided by 6, and it's equal to this right-hand side, which is 2 to the third. And then because these bases are the same, I could take the exponents and I could set them equal to each other. Now, when you get to Algebra 2, you're going to learn that we did what's called taking the logarithm. But we aren't going to tell you that now, okay? Now our next thing is to get rid of this ugly fraction. So we need to multiply by the least common denominator. So my 4s and 6s I'm a little rough with. So to find that number that I'm going to multiply by, I'm just going to list off my multiples of 4. And then I'm going to list off my multiples of 6. And I'm going to look through that list and see the first number that's listed. Okay, so both of these have a 12 listed. And so that's what I'm multiplying by here in my problem. So here we go. So 12 divided by 4 is 3. So this is 3x. And here, 12 divided by 6 is 2. So I get 2x. And 12 times 3 is 36. So then I collect my like terms. So 3x and 2x makes 5x. And then we divide out that 5 because it's multiplication. So I get that x is equal to 36/5. Which again, you can, actually do that division and get 7 point something, but it doesn't really matter. So there we have it. That is how to use the product of powers property. Until next time.